Welcome to MySQL webinar series from JPassion.com. This is our 8th webinar, and today's topic is performance. So let's start with the presentation. So these are the 4 major topics that we are going to cover in this presentation: query cache, indexing, and explain feature, and slow query log. So let's talk about query cache. So what is query cache? It's a cache where the text of a select statement and its response, the result of it, is saved. So if an identical select statement is repeated by the same client or a different client, the server will take a look at this query cache, and if there is a match, it will use the result from that cache. So this query cache is shared among sessions, meaning multiple clients can take advantage of the cache once cache contains a particular select statement and its result. The reason for using query cache is obvious, and especially is quite useful in an environment where you have tables that do not change that often. And the server receives the same request over and over from multiple clients. And this is in fact typical situation for many web servers that generate dynamic pages based on the data from a database content, meaning database content do not change, and mostly the request is coming from the clients for read operation. So query cache, when a table is changed, then the relevant entries in the query cache is discarded. So this is to prevent the cache reflecting wrong data, or in other words, prevent the query cache from being stale. By the way, the query statement is case sensitive. So select with a capital letter from person is different from select small letters from person. So result of this one are the same, but as far as query cache is concerned, these two are considered different. So MySQL maintains some system variables reflecting various statistical data on this query cache. So query cache size variable specifies the amount of memory allocated for caching, and as a default it is set to 0, which means query cache is not enabled as a default. Now cache type, query cache type can be one of the 3 values. If it is 0 or off, that means query caching is turned off. If it is 1, then query caching is turned on. If it is 2 or demand, then query caching is done on demand basis, and we'll see examples of that in a few minutes. As a default, it's going to be on, but the cache size is 0. So in a sense, it is like a caching is off as a default. Query cache limit maximum result set size. So result sets larger than this cache limit will not be cached. So if you want to see all query cache related variables, you say show variables like, and then query cache pattern, and then you will see the values of these variables. Here, query cache type is on, that means it is on, query caching is on, and query cache size is 1 million bytes. Now, how the query cache is working is reflected with runtime counter variables. So cache insert, query cache insert is basically total number of times queries are cached. So every time a query is cached, this counter will be incremented by 1. Cache queries in cache represent current number of queries that are present in query cache. And you can actually reset it to 0. Okay. And cache hits, basically number of times queries are hit. So of course, higher number of this value reflects that cache is being used quite effectively. So these are runtime counter variables. If you want to see those values, you say show status like and qcache pattern. So for example, let's say you perform a select query statement here, query operation here, and then you are going to see, suppose your query is turned on, then you can see it will be cached. So you will see qcache insert is going to be incremented by 1. And at that point, there will be 1 query in cache. So you can see these 2 variables are incremented by 1. Now, if you perform the same query statement, then you will see query hits is going to be incremented by 1. Selective caching is used when query cache type is on demand. So as we learned before, one of the type of cache type is on demand. So when you select on demand cache type, then you have to specifically specify whether you want caching or not. So in this case, if you want this select statement to be cached, and you have to say select SQL no cache. Yeah, actually no cache means you do not want this one to be cached. If you want this select statement to be cached, then you say SQL cache right after select statement. Then it will be cached. All right, so let's do our first exercise. So this is basically query caching the exercise. So we start already MySQLD, and then we start MySQL client. So this is join table without, so this is join table with index. So, basically we are performing some query operations. So let's try this. So here we created a table. We created the department table, we created employee table, and these 2 tables are interrelated through the foreign key. And then we have populated department table, and then we have populated employee table. And so let's just run that script. All right, so we have created 2 tables and populated those 2 tables. Now let's see the query cache for now. So for now you can see query cache is on, but the cache size is 0. That means there is not going to be any cache. There is not going to be any query caching practically. So this is the same thing as having this one as off. Okay. And in terms of runtime counters, they should be all 0 because nothing has been cached yet. Okay. All right. So now we are going to So we just saw this query cache variables. It is actually query size is 0. So practically, query caching is kind of the not being enabled. All right. So we are going to perform select operation here after we created these 2 tables. And again, you are not going to see any change in runtime counters because there is no caching. Okay, these are all 0. So now we are going to increase cache size to 1 million bytes. So now we are going to start the caching. So we are going to change query caching size to 1 million bytes instead of 0 byte. Okay. Now, if I take a look at the query cache variables, now you can see the query size is 1 million bytes, and because cache type is on, from this point on, caching will be enabled. Okay. All right, so now let's just have this one here. So now let's try to perform query operation, another select statement. Now this time, if we take a look at the cache, query cache variables, we now see number of insert is 1, meaning one query statement is inserted into this cache, and there is one query in cache. So this, when you reset the cache, then this value will be 0. Okay, even though this insert will be staying the same. All right, now execute another same query. So, but for now there is no hits. Okay, now if we perform the same select statement, okay, then let's repeat. Let's take a look at these variables. Now you can see this hit is incremented by 1. And if you perform one more time, then of course this will get incremented. So, oops. So this number of hits is incremented to 2. Okay. All right. So, and so that's what we have seen. And if we perform another different query statement, so let's try to perform different query statement, and this will be cached. So we are going to see this insert, number of inserts will be incremented to 2. Okay. Let's now take a look at the query variables. Now you can see the insert is 2. Okay. And yeah, so that's basically what we have done. Okay, and the number of queries in cache is incremented by 1 as well. Now, if you flush the cache, you can, if you want to flush the cache, you say reset query cache. Okay, now if you take a look at the query variables, you can see the number of queries in cache is 0, while the number of insert is still remaining to be still 2. Okay. Now, if we actually perform at this point another select statement, then you are going to see, as expected, number of inserts is going to be incremented by 1, even though it's the same query result before, and then the number of queries in cache, the number of present, the number of queries present in cache is incremented by 1, in this case to 1. Okay. All right. So that's basically what we have done. 1.5 is performing selective cache. So here we are going to show status. Yes, yeah. So this is what we have done, and here, in this case, is no cache. And yeah, so this is actually working even though, you know, this selective caching works when you are enabled with the caching. Okay, so it works both on on-demand cases and on case. Okay, so here is no cache. So even if you actually perform the same operation, in this case 1, yeah, actually it's different. Okay, yeah, so I'm going to actually use this lab documentation. So observe. This is probably something that we have cached before. Oh, I'm sorry. Yeah, this is actually a brand new one, and it's not going to be actually cached because you say no cache. Okay, so if you actually take a look at the number of queries in cache, is still remaining to 1. Okay, and so if we change this one to Well, actually, I'm going to just copy this one. So same thing, but this time we want to cache. In this case, number of queries in the cache is going to be incremented by 1. So this time is 2. Okay. All right. And you can turn off query caching by setting caching type to off. Okay. And then you can see the type variable now reflects off. Okay. And you can reset all the variables values, and then we can see the values again. Actually, runtime counter. Okay, so the number of queries in cache is 0. And here, even if we perform some select statement, okay, you are going to see nothing is being changed, okay, because we turned off the cache. All right, so that's pretty much regarding query caching. So let's move on to the next topic, indexing. Indexing is probably the most powerful tool that any database server supports in terms of performance enhancement. So what is and why indexing? You can think of indexing as logically a separate table that contains sorted values of a column. And in fact, you can have indexing for each of your columns of a table. So you could have multiple indexes for a table. And the reason indexing is powerful in terms of performance enhancement is because it prevents full table scan. So without indexing, full table might have to be scanned to find a match because you don't know whether that is in fact a row that contains a particular value until you actually read every the value. But having indexed table, you can see whether a particular value is there or not, okay? Because every value is in fact in sorted manner. And inserting or deleting a row from index column is more efficient. Again, if you try to delete a row using, for example, like a where clause, you don't have to actually scan the whole table to find it whether there is in fact a row that actually matches that value. Instead, you can use index column and you can find whether there is in fact a row that matches the value for deleting or inserting. Indexing is actually quite powerful, even more powerful when you are doing queries involving joins on multiple tables. In fact, most of the queries actually involve multiple tables. So by having indexing, you are going to improve the performance quite drastically. So in a single table, the number of values you need to examine per column is the number of rows in a table. So if you have 10 rows in a table, and if you want to find a value, then you just have to take a look at 10 rows. However, in joint operation, you are dealing with the multiple tables, and the number of combinations that you have to actually take a look is exponentially increasing. Okay, so basically, it's a Cartesian product number of read that you have to do. So I'm going to actually use that one. I'm going to explain that one more time using an example in a few minutes. So in MySQL, indexing is used in various places. As I mentioned before, when you have a where clause, that's where the indexing could be used to find whether there is a row that matches the value in where, or rows that match rows in other tables while performing joins. So when performing join query, again, indexed table, the indexed columns are going to be very much useful. Also, queries such as queries that use mini and max functions. Again, you can find out minimum and max numbers, max values from the indexed column rather than scanning, again, whole columns. MySQL often use indexes to perform sorting and grouping operations quickly for order by and group by clauses. So these order by and group by actually require some sorting, sorted values. So by having the indexed column, it's going to be a lot quicker. So example query. So this is the example query that explains why indexing is such a powerful thing, especially when you're dealing with a join query where multiple tables are involved. So let's assume we have three tables, T1, T2, and T3, and each table contains a column, C1, C2, and C3. And let's assume each table contains 10 rows. So T1 table contains 100 rows of C column, and same thing for T2 and T3. Now, if you have performed a select query statement like this, so you want to display some columns of T1, T2, and T3 from these three tables, where the value of column 1's value of T1 is the same as T2 C2 column, and also here column 1 value of T1 is the same as column 3 value of T3. So here we are involving three tables and three columns of those three tables. So in this case, without using indexing, the possible number of rows that you have to scan is 1 million, because you have to scan all rows of table 1 times all rows of table 2 times all rows of table 3. So 100 times, 100 times, and 100 times, 1 million. Because there is no way that you can find out a particular row of a table contains the value that you want. So basically, this is why without indexing, the join query operation could be taking a long time. Now, if you're using indexing, for example, T2 have a column on, the T2 has C2 column of T2 is indexed, and C3 column of T3 table is indexed. In that case, the number of rows that you have to scan is just the first table, 100, and then you are going to find the value in second table right away. Same thing, you can find the value in the third table right away. So basically, the number of rows that you are going to scan is 100 plus 1 plus 1. So just 102 instead of 1 million. So it's very, very efficient. All right, in terms of which column you want to index, obviously indexing has an overhead in terms of maintaining a logically separate table. So you do not want to index every single column of every table. So you want to index columns of a table when the columns are used in where clause, when columns are used in where clause, or when columns are named in join clause, or when columns are appearing in order by and group by clauses. So these are the cases where those columns, when they are indexed, will provide faster performance. And you don't want to index columns that appear only in output column, because that doesn't really help them much. So let me actually give you an example in the following slide. So suppose we have two tables, T1 and T2. So here we are just displaying C1 column of table 1. This one you don't need to index unless this C1 is also used someplace else, for example, like a where clause and a join statement. Okay, because it's not used in join statement where clause, you don't have a reason for indexing column 1 of table 1. Now here, in this case, in here left join statement, we have column 2 of T1 and column 3 of T2. In this case, having index value of C2 of table 1 and having index value or index column of C3 on table 2 will be useful thing to have. So so those two columns are good candidates for indexing. Also, when that column 4 in this case from table 1 is in where clause, again C4 column is also a good candidate for indexing. So the only candidate that is not required to be indexed is in this case C1 column of table 1. Column cardinality. So database has the table has the concept of column cardinality. What do I mean by cardinality of a column? It's a number of distinct values that it contains. So for example, if a column of a table contains values 1, 3, 7, 4, and 7, and 3, then cardinality of this column is 4 because the number of unique values, distinct values are just 4, 1, 3, 4, and 7. So indexed column work best when there is a very high number of cardinality, high number of cardinality value, meaning the more distinct values. Okay, because distinct values are actually representing different different rows in that column. All right, so in terms of indexing, MySQL provides again various runtime counters. So the only thing that I want to actually spend time for explanation is maybe this. So when you have handler read R&D next, it represents number of requests to read the next row in a data file. So if this value is high, then you are doing a lot of table scans. So generally, this suggests that your tables are not properly indexed or your queries are not written to take advantage of the indexes you have. So when this number is high, and then you might want to actually see how you can actually optimize your query by having some columns to be indexed, or you actually have a query statement that take advantage of the indexed columns. All right, so let's do exercise 2. So this is again the same. So we are going to actually try two things. The first, we are going to perform query operation without the indexing, and then we are going to do the same query with indexing. So here we have, so this is the SQL file that contains creating tables. So you can see there is no indexing here. Okay, so there is no index column in these two tables. So it is the departments table and employees table, and none of the columns in these two tables are indexed. And then we populated it. So what we are going to do is we are going to take a look at the handle read, so those the variables before this join operation and after join operation. Okay, and we'll see. So this is a case that we do not have any indexed columns. So let's actually run that one. Oh, I'm going to just run this one. Okay, so now what you find here is so this is a case that, so this is actually very high number. The reason it's actually high number is actually I play around with this MySQL statement already. So let me actually just restart it so that we have something close to the documentation. I'm just starting again. Okay, so it probably doesn't make any difference because the values are from MySQL server, which I have not restarted. Okay, so we're gonna actually restart the MySQL. Okay, so we don't really have to do this, but I just want to be the same. Just kill this guy and start my. Okay. And use my DB. Okay, now I'm gonna run this one. so that we actually see the, well, the values in the documentation. Okay, so this is what you see here. The number of read next is 11, so which is pretty high number, which means that it's not really, this query operation, either this query operation does not take advantage of index column, or in this case, you don't have columns that are indexed. Okay. So now the next thing is we are going to actually try we are going to recreate a table with indexing. So here we just use this the indexing for ename column. Okay, so because ename is used in the join operation here. Okay, and again we are going to see the runtime variables before and after this join operation. Okay, so let's run this guy. Oh, this is actually still 1, so I have to restart it again. Okay, now we are going to use the SQL file that contains creation of the table. One of the table will have index column ename. Okay, now you can see this value stayed 0. That means it doesn't actually, it's like 11. In previous case, it was 11 when indexing was not used. Okay. All right, so that is indexing. So let's move on to the next topic, number 3 topic, explain. So what is explain? Explain is used to find information where you want MySQL to explain how select statements are being performed in terms of which optimizer it uses and things like that. So it basically is used to obtain information about how SQL executes your select statement. So you're going to use explain just before select statement. And then MySQL will explain how it processed that select statement, including information about how tables are joined and in which order. So the reason you want to use explain is to find out if there is any the operations that are not really performing as expected. So with the help explain, you can see where you could add indexes to tables. So or get a faster select query operations. And you can also use explain to check whether optimizer joins the tables in optimal order. So MySQL has what is called the optimizer. Optimizer is the one that actually performed the joining tables in optimal manner, and you can actually find information about that. So explain fields. So the data that it will display includes a few things, and the table indicates which table the output is about, and the type is what type of join is being used, and in fact there are a few different type of joins, and so when you see all, that's not really that's the kind of worst kind of join. Important information you want to see is possible keys. Indicates possible indexes that can be used by MySQL. Means if there is no possible keys, that means there is no index column is taking advantage of. Key indicates which index among ones in possible keys actually used. So you have a possible keys, which is index column and primary key, and then key is the one that actually which one is actually being used for your query operation. So if you actually see possible keys but not in keys, that means you might in fact have a column that doesn't have to be indexed. And rows is number of rows MySQL believes it must examine to get the data. So this is basically indicating when you have a high number of rows, that means you are not really taking advantage of indexing. Either the indexing the columns are not indexed, or query operation is not really optimizing that index columns. So when this rows values is small, that means indexing is actually used effectively. So this is non-indexed query. So in this case, you can see, again, this is the, we're going to actually do this one in a few minutes using departments and employees tables. So here, number of rows 5. So we have actually employees table that has a 5 rows. And here we have a department, the table that has 4 rows. So when you perform the join operation for these two tables, you can see the full scan of those two tables are done. So this is a Cartesian product scanning that we talked about before, 5 times 4. Okay. Now, if you have a column to be indexed, then you can see the number of rows, and number of rows in this case both 1. Okay, and you can see possible keys is ename and in this case foreign key, and the actual key that was used is ename, which is index column. Okay. All right, so let's do exercise 3, and that's basically the what we saw in the presentation. So again, this is the SQL file that we again create the employees and the departments. Again, this is a case that we do not use indexing. Okay, and then we are performing select statement with explain. Okay, so let's run this guy. Oh, I have to run this one. Yeah. Okay, so you can see the number of rows of employees. The rows of employees table that are scanned is 5. So we have a 5 records in employees table. Again, in departments, it's scanning it scans all rows, number 4. Okay, so if you take a look at the from employees, we have a 5 people and 4 departments. We have 4 rows. So both tables actually completely scanned, okay, because we did not use index. Now we are going to run this SQL file that now contains index column. Again, this is the same the ename index column. So let's run this guy, and again we are asking MySQL to explain it. Okay, so let's run that one this time. And you can see the number of rows that it has to scan is just 1 each, so which is a lot efficient than the non-indexed case. Okay. All right, I'm gonna actually skip this exercise 3.3, which is actually working against the Sakila database. So let's move on to the next topic. The last topic is slow query log. So what is slow query log? So MySQL basically can log any slow query operations. Okay, and these queries are the candidates for optimization. So in order to see the threshold, you can see long query time. So for now, this is set to 10 seconds. So it will log any query operation that takes more than 10 seconds. And as a default, it is actually off. So in order to enable it, you have to set slow query log to on. So you're actually enabling the logging. And then if you display these slow query log variables, you can see it is on, and the log file is specified right here. Okay, and then once you performed a very slow query operation, then if you take a look at the log file, then it will display all the query operations that take longer than the threshold. All right, so let's do exercise 4. So we are going to see what is the default values of this slow query log feature. So as you can see, it is off as a default. Okay. So we are going to, and then we also want to see what is the threshold value. So that threshold value is set on long query time. So let's see the default values. The default value is 10 seconds. So unless your query operation takes more than 10 seconds, even if you enabled the logging, it will not log it. Okay. So this time, let's actually enable this slow query logging by setting this global variable to on. Okay. Now, if I actually see, now it is on. Okay. But the threshold is still set to 10 seconds. Okay. So now let's actually perform some join operation. So I'm gonna just join operation. Okay. And then we are going to actually see whether this log file has been created. At least it's created. Okay. So I'm gonna just open another one, and I'm gonna just see the contents. So it has been created, but nothing has been logged because we did not perform an operation that takes more than 10 seconds. So this time we are going to set this threshold to very small. Okay, so here I'm going to set this long query time threshold to very small. So every operation that we are going to perform is going to be logged. And now if I take a look at the this threshold value, we just verified that this is set correctly. Okay. Now we are going to perform some join operation, which is going to take more than this very small amount of time. Okay. Now if I actually go back to and take a look at the same file, now you can see it contains information about the query operation that we have performed. Any operations that took more than that 0.00001 second is logged. They are logged. All right, so that is pretty much what I have. So let me